Hi, welcome to lesson S.4.2 on double-ended questions. Um, we're dealing with the Z-score still. So the Z-score tells us what percent of the data lies to the left of the test point. And we need to look at what do you do if you want to know the percent to the right. So the question in example 1 is, what percent of Tony's dogs weigh more than 55 pounds? Recall that the mean is 52.5 pounds and the standard deviation is 4.2 pounds. So anytime there's a percent question in this, you're going to be using the Z-score. So I'm going to write down my equation. Z equals x minus mu divided by sigma. And x is my test point, which is 55 pounds. My mu, my mean is 52.5 and my standard deviation is 2.4. So I'm going to plug all those into my equation. So I get 55 minus 52.5 divided by 2.4, and that equals 1.04. I look that Z-score up in the table and I get an answer of 85.08%. But that is way less than my 55 points, right? Because that's how much is to the left, less than that. So to get how much is more than that, I do 100 minus 85.08, which gets me 14.92%. And that's how much, it's not how you spell way, way more than 55 pounds. All right, that one was pretty straightforward. The next one is a little bit more involved. So let's do example 2. What percent of Tony's dogs weigh between 52 and 53 pounds? So I'm going to do a quick sketch. Quick, terrible sketch, probably. All right, we know that our mean is at 52.5. And we want to know how many are in this little bit here, okay, between 52 and 53. So what we need to do is figure out what percentage are less than 53, which is this yellow range, because remember we can only find what's to the left of a particular amount. So if we do that and then we subtract the bit that's here, we can be left with what we actually want. Okay, so I'm going to write that up and I'm going to say that the percent of dogs between 52 and 53 pounds is the percent less than 53 pounds minus the percent less than 52 pounds, because that's going to be the yellow bit minus, well, I'm going to use a green, less the green bit. Okay, so that equals some number minus some other number is going to get me my answer. Okay. All right. Let's do the yellow bit first. So my x1, my x, I'm going to call that x1, is 53. My mean is 52.5. My standard deviation is 2.4. So z equals x minus mu over sigma. 53 minus 52.5 divided by 2.4. That equals 0.21. I look up that in my Z-score table and I get 58.32%, which I will write up here, 58.32%. And I'm just going to color that yellow so that we can follow where the numbers come from. Okay, and then the other one, x2 is 52%. My mu is still 52.5. My sigma, 2.4. Z equals x minus, oops, x minus mu over sigma. 52 minus 52.5 over 2.4. That equals negative 0.21. I look that up in my z-score table. I get 41.68%. 41.68%. I'm going to color that green. I'm actually going to circle it because I don't know how well the green will show up. If you can read through it when we're done. And then I just subtract those two numbers and I get 16.64%, and there's my answer. Put a box around it because it's not at the bottom of my work, so it's sometimes hard to find. And we're done. Okay, hopefully that made sense. Let's do example 3, which is even more complicated. Surprise, surprise. All right, the ABC company produces bungee cords. When the manufacturing process is running well, the lengths of the bungee cords produced are normally distributed with a mean of 45.2 centimeters and a standard deviation of 1.3 centimeters. Bungee cords that are shorter than 42.0 centimeters or longer than 48.0 centimeters are rejected by the quality control workers. If 20,000 bungee cords are manufactured each day, how many bungee cords would you expect the quality control workers to reject? So we have, we need to figure out what percent of those 20,000 we need to reject. So we're looking at a percent, and it's a normal distribution. It tells us that. So I think that anytime we're told it's a normal distribution, we should just sketch that normal distribution curve because it's probably going to help us understand what's going on. All right, we've got a mean of 45.2. That's our mean. And anything that's shorter than 42.0, we're going to reject. Oops. And anything bigger than 48.0, we're going to reject. So, oh, it doesn't like drawing things, coloring things. Okay, so the percent rejected is going to equal the percent that's less than 42.0 centimeters plus, this time we're adding it because the two chunks are separated, plus the percent less than 48.0 centimeters. So it's going to be some number plus some number, which is going to equal something, which is the percent rejected. But we're not going to be finished then. Okay, we have to remember to come back and figure out the number. So I'm actually going to write a little bit more down here, and I'm going to say we're going to reject some percent of the 20,000 so that I know I've got more work to do there. All right, let's do the first part. So if x1 is 42.0 centimeters, mu is 45.2, and sigma is 1.3. I'm going to have my z equals x minus mu over sigma is 42 minus 45.2 over 1.3, which equals negative 2.46, which I look up in my table and I get 0.69%. So I'm going to write that up here, 0.69%. And I do like to draw arrows to show where things come from. Okay, so that's where that comes from. And then we're going to do the same thing, and I'll maybe do this in a different color with x2 is for 48 centimeters. And my mu is 45.2, my sigma is 1.3, z equals x minus mu over sigma equals 48.0 minus 45.2 divided by 1.3. This is 2.15. I go to my table, I get 98.42%. Okay, wait a minute, that doesn't make sense. I'm not going to reject 98.42%. Oh yeah, I need to change that to 100 minus that, right? Because that gives me how much is to the left of my 48. I need to know what's to the right of my 48. So I've got to go 100 minus 98.42, which equals 1.58%. And I'm going to write that up here, 1.58%. And I'm going to draw a line. There we go. So I've got my two numbers. I'm going to add them together. And when I add them together, I get 2.27%. Okay. And I didn't really leave much room up here with my yellow highlighting. I didn't think that through all the way, but it did have it there to remind me. So I'm going to come down to the bottom, and I can now do that. I need to reject 2.27% of 20,000 bungee cords. So the easiest way to do that is change my percent to a decimal, 0.227 times 20,000, which equals 454. Therefore, we are going to have 454 bungee cords rejected. And I'll put a box around that. There we go. That wasn't so bad, was it? That's it. That's the last example for this section. Go do the homework. The next section I think is actually easier, the next lesson. So go do the practice and then check out the next video. Bye.